Welcome to the Defense and Aerospace Report. I'm Vago Muradian at the Association of the United States Army's annual conference and trade show in Washington, D.C., and we have Rich Choppa with us, who is with a brand new Boeing organization, Boeing Strategic Defense and Intelligence Systems. I'm very glad. I'm very pleased I got that right. Rich, tell us a little bit about what we're looking at. Obviously, drone and counter-drone is, drones are the hot thing, and now as soon as something gets hot, then everybody's trying to figure out how to stop them. Tell us a little bit about this system you guys have developed.
So this system is called the Compact Laser Weapon System. It is a small laser. It's the smallest laser weapon system that's out there. It was designed specifically to shoot down as a counter UAV system. It's able to shoot. We have successfully shot down counter UAVs at MIFIX, Maneuver Fires Integration Exercise 2016 in April. We were able to shoot down 20 quadcopters. As you can see, one of the quadcopters with the holes from our laser weapon at ranges beyond 1 kilometer. We have built this system to do that. For over 20 years, we've been investing in systems and have been shooting down UAVs since 2007. So this system we developed specifically to meet, as a quick reaction to meet the current threat that's out there. Yeah.
Tell us a little bit about what kind of, how long the laser's got to be on target before it gets a result like that, and how quickly you can train, if you're tracking and you're dealing with a swarm or multiple contacts, how quickly can this system go from one target to another, engaging and shooting them down?
Right. So first of all, let's just talk about how it's used. It's very easy to use. We actually set it up. It's the system. We use a tough book and a PS3 controller so that anybody under the age of 30 automatically knows how it works.
That is brilliant technology right there. Anybody who wants defense transformation, that's it.
It's like a video game.
Just with real lasers. So.
Right. The amount of time it takes to shoot down depends on range. It depends on the hardness of the target. If you're shooting at a sensor on the target, so for example, as you've watched in Ukraine, as the Russians have used UAVs as a sensor to direct artillery, if you're doing it in a counter sensor mode, in a fraction of a second, you can kill their sensor. If you want to shoot it down, it takes several seconds, but in the single-digit seconds to shoot down a UAV, and again, dependent on range and weather conditions, etc. But it's a neat system. It's as I've said, we've tested it. We're trying to get it fielded and get it out there to the Army to give the soldiers something that they can use to defeat this threat, because right now there's nothing.
Rich, that's for military applications, but talk to us a little bit about civil applications. I mean, drones are proliferating. It's like the fastest growing holiday gift market, but it's also something that gives, whether they're Homeland Security or law enforcement or even, private citizens, fits about where we're going to get to in a couple of years. What's the potential Homeland Security threat from these kinds of unmanned aircraft? And how can this be applied in metropolitan areas, for example, for area defense?
So first of all, this system is speed of lights. It is also very accurate. It locks on the target and it doesn't move off the target, so it minimizes the collateral damage. So there's no impact from it's the same as putting in a acetylene torch with a dime-sized spot on a target. So if you could imagine a drone in a civilian area, like we've seen at the White House, we've seen around Capitol Hill, near airports, at football games and big events. If you can imagine a drone with a explosive device hanging from it, this type of system could explode the device, could knock this down and keep it away from people. So, and it does have civil application. There's of course, some regulatory requirements that would have to be met, but certainly I could see this in the Washington area, in the National Capital Region.
Better living through lasers.
Absolutely.
You guys obviously have vast experience with lasers. Obviously, Airborne Laser was a program you guys were associated with, which was sort of the mother of all lasers, on a 747, and gained valuable lessons from that. Atmospherics is always a challenge. What are some of the atmospheric limitations, if there is that, for this system, especially when you're in the denser, lower atmosphere?
Right. Well, as you know, under 3,000 feet, you're in, we call it the soup. Because of the ranges on this, you just have to power through. But we have tested this in rain, mist, dust, of course, sunlight. There are some effects, but in general, you'd be surprised that this thing will work in in any weather conditions. And frankly, against the systems that we're using this against, the optics on those systems are degraded as much as the optics on this system. Sorry.
But that was designed to do that. How long before this becomes actually a program of record and you guys are actually delivering a capability?
So right now there are no programs of record for laser weapon systems. All of them are in the development. This was developed on Boeing internal research and development funds. We are hoping, we would love to see a program of record come out to recognize that there is an issue out there, and even as the Undersecretary for Acquisition Technology and Logistics said, for laser weapons, he sees that these types of systems are the only way to shoot down UAVs to conduct the counter-UAV mission.
And I know that you're very eager to answer this question about price point, but what kind of a price point are you looking at? Obviously it's volume dependent,
right.
But what is that rough number that you guys are shooting at, which will be the price point that will actually cause it to proliferate in the Army as, something that the Army will want to buy in volume?
Well, eventually we'd like to get below $1 million for each system. Right now, of course, these are one-off systems, but eventually we could see these things vary. If you think about it, as a cost per shot, the price to shoot one of these systems is $1. Right now, the missiles that they're using to shoot down UAVs, a Patriot costs $3 million. So if you think about it from the cost per shot perspective, it's a great deal. It probably costs a little bit more to build a system up like than it is to have a launcher for a missile, but the cost per shot is way lower, and the sustainment for a long term is a lot cheaper if you think of the logistics trail to get missiles in country.
That's right, and the fire control solution is really simple at the speed of light, so you're not even leading anything.
Right.
Quick question about what other support equipment is required for this. Lasers have a tendency of requiring large capacitor banks,
right.
Or chemical iodine, right?
Sure.
Obviously was the ABL challenge and issue there, right? The transition to solid state. But what are the ancillary equipment that you require with this? Do you need it to be cued by a radar system? If so, what kind of radar system? And then what sort of power does this require? Is this a self-contained unit, or does it require its own separate generator?
So this is a self-contained unit. It was designed to run in the man-portable or the compact man-portable mode, where it would be delivered in Pelican cases and run off a capacitor pack, basically a battery pack. It can be slaved to the alternator on a vehicle and run continuous power off a vehicle. So if you think of that, unlimited magazine. So as long as you've got fuel in the tank, the weapon can fire. It has a chiller. In addition to this, it has the laser, the chiller, and the battery pack that run with this system. The total package weighs about 400 to 500 pounds, depending, right now. We certainly expect that everything will get smaller as we go from these one-off designs into, fully manufacturable systems.
And how many shots do you get off of that capacitor pack?
That's classified, and it also but it depends is the answer. You can get. Depends on the length of lays, the range, the hardness. If you're shooting at a sensor, a fraction of a second versus multiple seconds, and that will determine on the battery pack you'll get a certain number of shots. But it is, you get significant capability just firing it off the battery pack. And as I said, firing off the vehicle, unlimited.
And obviously atmospherics would be another thing. Obviously that would. And what about queuing? What sort of systems do you use for queuing?
So this system at MIFIX 16, we showed this system tied in with the FAD-C2 radar, FAD-C2 system. It had multiple different radars and acoustic sensors that we queued it. We were able to take a queuing off the network and queue the system. This will slew to the general area. The optics will pick it up into a rough track, and then the operator can put it onto the critical point. On a quadcopter, it's the engine. On larger UAVs, it may be the control wires for ailerons or rudders.
Rich, thanks very much. We appreciate it. Best of luck on the program, and best of luck in the new organization.
Thank you very much.